Okay, hello everyone. The time is 5:48 p.m. Wednesday, June 8th, which this marks day 10 of coding every day to prepare for full time. I did notice I got a comment the other day on this video. Oh, also, this video did get restricted because it had music playing in this section, so I guess no more music. It's getting wicked out here. We are going to continue. Is there like a bound on this? Oof, interesting. I feel like it's going for infinity. It's a beautiful Christmas tree. But yeah, we're gonna continue this. We're gonna continue just kind of like finishing off a section. So we got 2 mediums and 2 hards. I'm thinking for today, I will do the medium and the hard, and I'll call it there because that hard's probably going to be very difficult. I've only done one LeetCode hard before, and it wasn't even like a real LeetCode hard. I mean, like it was, but it's like it was literally just pretty much an advanced graph question, and I literally just studied that advanced graph question for my algorithm exam, so it didn't even matter. So I just kind of like knew it like by memory. If I was to go back and try it again, I wouldn't be able to pass it. Oops, I don't want to solve it here. Solve it here. Okay, this is 2-pointer. So I gotta remember how to do 2-pointer. Container with most water. You are given an integer array height of length n. There are n vertical lines drawn such that the 2 endpoints of the ith line are I of 0 and I of height. Find 2 lines that together with the x-axis form a container such that the container contains the most water. And then this just kind of outputs the max here times the length. So we have in this instance we have 8 and 8. Oh no, 8 and 7. Ooh, see, there you go. That's the trick. This is from calculus, right? Where you're trying to find the maximum potential area given certain length and width and use a differentiation. I'm gonna take the hint first. Oh wow, you get 3 hints. If you simulate this problem, it will be Olven squared, which is not efficient. If you simulate this problem, what does simulating it mean? Just like go 1 by 1? Right. Try to use 2 pointers. Set 1 pointer to the left and 1 to the right of the array. Always move the pointer that points to the lower line. Oh! I guess I could do sort of like almost like a sliding window approach. Is that sliding window? So what I'm thinking I'm not going to use the SkyLight for this one, but what I'm thinking is similar to what the hint just said, is we'll just calculate the max at each point. So we're going to start a left pointer here, a right pointer here, and then we're going to keep calculating the max for each one. And then if, or not the max, the area, the current area. And if the current area is bigger than the current max we have, then we're just going to set that so. Let me see, I'm guessing there are no negative heights? Right, no negative heights. So I could say max area equals to 0 starting off with. And then I'll say left pointer is equal to 0. It's the index. Right pointer is equal to the length of height minus 1. And then I'm basically going to say wall left pointer is, stop with the parentheses. Wall left pointer is less than right pointer. I'm going to say max area is going to be equal to the max of height of left pointer times height of right pointer, and then max area. And then I'm going to basically say, I'm basically going to move the post. So if height of left pointer is less than height of right pointer, which means the left side has the smaller values, then we want to actually just move that next. Then we're going to say that left pointer plus equals 1, else that means the right pointer is the small one, so we want to move the right pointer inwards. We're moving them inwards. And then we're going to just return max area. Okay, let's run the problem. Okay, so that's not the solution. So I got 64. Oh, wait. I'm tripping. I am tripping. It is max of... This is a pretty gnarly looking thing that I'm about to write. So it's the max height times right pointer minus left pointer. So this is 49 because of 7. So 1, 2, 3, 4, 5, 6, 7. Okay, I think that is right. We'll see. I'm wondering if I'm about to do plus. Huh. I just need to visualize what's happening here. So we have 1 times 7 multiplied Huh? Oh. Oh. Sorry. I was confused. What? So I got 56 here. Oh! I'm doing the max. Silly, silly, silly Billy. Yep. That's why. Okay, so basically, I was grabbing the max of the two towers, which makes no sense because, like, this, for example, this is a max, and if you were to reach here, the water would spill over the top. You would have to have the min. So, this is more like it. We'll see if that works, if that submits. And it does. That problem is actually pretty fairly easy. Oh, okay, buddy. Cat's rolling around. I'm scared. Here we go. Time to do the hard. I like the fact that the hard has no hints whatsoever. Like, wow, that's amazing. Thank you. Given n non-negative integers representing an elevation map where the width of each bar is 1, computate how much water it can trap after raining. Okay. So for every small value, it needs a big value. So for every value, it needs a value greater than or equal to it, so that way it can store something. And the edges don't count. So I could see, yeah, like 2-pointer being a solution here, but it's like typically 2-pointers like from the very end to the very end, you know? This one seems a little bit more different. How did I do 3 something? My brain's thinking of doing like 4 pointers. You know, like a pointer on the left, a pointer on the right, and then like 2 pointers in the middle. But it's like, even still, like, why would that matter? You know? Because if that was the programming logic, then as the, like, you could have 2 sides that have this, and then boom. So 4-pointer won't work. It has to be, it probably has to be 2-pointer, just in a very specific, smart way of going about it. My second thought is to start with your left pointer here and then your right pointer here, and basically doing like a slow fast kind of situation, where you move your left pointer. Sorry, so you have your left pointer stuck, and then you move your right pointer until you find a value. Let's see. I'm gonna draw this out so I can just like see it. Oh, don't troll me now. Like pointer here, then like one here, and then basically this will move here, and once it sees something bigger, it'll be like, yo, check it, keep it, and then it's like, can I make something with it? At the moment, not really. So then we're going to move red here. Move red here. Let me use my mouse pad. Move red here, and then blue will start moving forward. So then blue will basically go here. It's less, can't do nothing with it. It'll go here. Hey, it's greater. So then we'll track the amount of water. So then we'll run a count. Right? Okay, and then once it hits that bigger, it will switch it. So say, oh no! Okay, so get rid of the count, because the count's not gonna work. So once it hits that bigger area, we're going to then switch red to here. And then we're going to put blue back here, and we're going to continue bouncing. So it bounces here, nothing, here, nothing, here, nothing, here. Whoop! See something bigger. So then we're going to do the count function that gets everything here. And then we're going to move red back over here. But here's the problem. Is we'll never get that blue. It's gonna keep going until it's in the end. This is where the benefit of like going from both sides would be. So after you do that, if you can then go from the other side, which will make it 2 of n, 2 of n. But then you have to make sure you don't count these ones. Will you ever run into these ones? If they're equal, of equal ground, yes, you will. Alright, I'm gonna do my shitty idea first, and then I'm gonna check a hint after I fail it, just to try it out. So basically, I'm gonna say left pointer equals to 0, right pointer equals to 0. I'm gonna say while right pointer is less than the length of height, I'm gonna say rain count say potential rain equals 0. Oh, should I get it? These mosquito bites are killing me, brother. I'm gonna say if right pointer, sorry, if height of right pointer is greater than or equal to height of left pointer, then we're gonna do a rain out. So I'm gonna say rain count plus equals potential rain. Alright, rain out we're going to do plus equals potential rain, and then I'm going to do left pointer is going to be equal to right pointer. Else, I'm going to say potential rain is going to be equal to height of left pointer. Oops, sorry, not equal to, it's going to be plus equal to height of left pointer minus the height of right pointer. Okay, grabs up the potential rain. And then I'm going to say, no matter what, right pointer needs to move. Right pointer plus equals 1, no matter what. Okay, so that should grab it from the left side. So what I'm going to do is I'm going to return rain count. So I'm expecting, if this works how I'm expecting it to have 5 for this output. So let's see. That's not good. That's really not good. print left pointer. Oh. Here you go. That's my problem. I never reset the potential rain, which gives me even more roll. No, Apple 5. Yes. Perfect. Perfect. Okay. That's exactly what I wanted. Okay. And then I'm going to basically say, I'm going to do the reverse side and say right pointer is equal to length of height minus 1. And then left pointer is going to basically be equal to right pointer minus 1. And I'm going to say while left pointer is greater than or equal to 0. Okay, I am curious to see if that runs. And it does. Alright, let's try to see if that works. I don't think it will. It's probably going to crash on something. Okay. So my output was 4. Oh, because I forgot to check for duplicates. So in this version, it has to be strictly greater than. Because holy shit, that worked! What the hell? Dude. And no hints either. Oh my god, this is what dreams are made of. Oh my god. Oh, hell, dude, that feels so good. Oh, that feels so good. Dude, didn't I just start this? I started like 5:40. Crap. I can't end the video now, it's too soon. Alright, screw it, let's keep going. I'll eventually hit a problem that makes me want to put my head through a wall. Ooh, this looks like it. This looks like that problem. Let me, try some stuff. Alright. There are in cars at given miles. Huh? There are in cars at given given miles away from the starting mile 0, traveling to reach the mile target. Oh. You were given 2 integer arrays, position and speed, both of length n, where position I is the starting mile of the ith car, position I is the speed of the ith car per mile. Wait, okay, sorry. You are given two integers, a position and a speed, both of length n, where the position is the starting mile of that car and the speed is the speed of that car in miles per hour. A car cannot pass another car, but it can catch up and then travel next to it at the speed of the slower car. Okay. A car fleet is a car or cars driving next to each other. The speed of the car fleet is the minimum speed of any car in the fleet. If a car catches up to a car fleet at the mile target, it will still be considered as part of the car fleet. Return the number of car fleets that will arrive at the destination. This is using the stack. This problem, like, makes sense when you're listening to it, but I could see this being kind of a pain to work on. So I'm guessing we probably want to solve this in O time. Yeah. Let's see. O of n log n. Well, crap, that kind of just gave stuff away, no? I mean, that I feel like that kind of told me that I need to sort. I can only sort one of them, and then I have to make do with the other one. So if we draw this out, you know, I actually, real quick, I am curious before I move on. I want to see if, like, the way I solve the trapping rewater is how you're actually supposed to solve it. I definitely did not solve it the proper way. Interesting. Well, my solution got me the answer, so I'm not mad at it. This part's gonna hurt me. So I'm thinking about like drawing each thing, but I was like, that's 1, 2, 3, 4, 5. Anybody that's 60 squares. Well, I would have to draw 60 squares. I would only have to draw 17 lines. But I'm lazy. Oh wait, I didn't think to count the time. Are they all at time equals 0? So like I guess they all start out at the same time. This one's 10, now it's 12. This one's 8, and then now it's 12. So that's at the same time. This one is 0, and then now it's like 1, 2, 3. Shoot. It's kind of chopped, but you know, whatever. Then we have one that starts at 5, which is like here. That one goes up by 1 as well, so that one's never going to get caught. And we have 3, which goes up by 3. And then now it goes up by 1. So these two will end at the same time. So let's look at the time. We have 1, 2, 1, 2. 1, 13. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I might be misunderstanding this because this is 3, but okay, yeah. Whoa, what's... Oh, the number of car fleets. Oof. It's even harder. This is a very interesting problem. So it's logical to sort this array based on their positions in descending order. Why? I mean, I don't fully know why. I'm not. I'm missing how I'm gonna actually like track that. Like my first thought is, okay, well, what we'll do is we'll match it by like slowing the speed. So if the bigger one has a smaller speed, then they kind of like match up. But I'm guessing that is the point. But it's just like, how do you track that if it matches up? Like if I basically go do the largest number and then I go finish it off, because that's the number being caught up to, right? Like, for example, this one right here, this is the one being caught up to. This one is being caught up to. Even though they technically meet at the same time, they're being caught up to, is the terminology here. But it's like, how do you, per se, know? For this one, it's pretty easy, because like, we could just say they hit the same amount of turns no matter what. This one, not so much, because this one jumps 3, then it has to match the speed for the rest, right? So I need to know that whenever I'm jumping on the third value, I need to know that, hey, 6 is going to, once you hit 6, you need to slow down. If you hit 6 on number 2, you need to slow down. I have to know that. Okay. Because a car can only form a fleet with another car that is ahead of it, sorting the array in descending order only assures clarity about the final speed of each car. Sorting in ascending order could create ambiguity, as the next car might form a fleet with another car while reaching the end, making it more difficult to determine its final speed. I'm guessing maybe this is where the stack comes in? Maybe like this is like you're popping and then putting it back in. Okay, let's continue onwards. Calculating the time for each car to reach the goal is a straightforward and can be done using that formula. The time equals target minus position divided by speed. Now it becomes easy to identify that 2 cars will form a fleet if the car head has a time that is I think I'm like smidgingly understanding, but like I'm feeling fried right now. Like
it's not like piecing together properly. Not gonna lie, I want to probably just do this another day because I am burnt out. I'm not feeling it. Take me back to 2-pointers. Back to the good old days of 2-pointers. So basically, like, no matter what the last one, like, if it matches up to this one, then it will basically kind of go with it. I'm trying to think. It's like, okay, so if I have like, let me do like this 10, 8, 5, 3, 1. So I find out this 10, 8 matches with this 8, then we're good. These become a thing. But like, let's say there's a 7 here that matches with this 8. So then if I hit this 8, then that means I need to match with this 10 as well. How do I find that? Do I store somewhere that, like, hey, that 8 matches with the 7, and if 8 is in this array, then add 7 to it, else make 8, 7 its own array? Oh, wait. So what I'm going to do is
exactly what that problem says is like, I'm just going to say, because this might take 2 seconds, and if this reaches it, and like let's say it reaches it, then it'll also then take 2 seconds. We'll match that as this time. Yada 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 yada. I think you get the point that I'm trying to say. Okay, how do I sort that? I don't feel I was gonna go make my own sorting, and then I decided I'm not going to. I'm not gonna look at the actual solution. I'm just gonna look at how he sorts it. Thank you. Max, you're gonna be fine. Cat's hungry, but dinner time is gonna come up pretty soon, so I'll feed him in a second. His dinner time is 7 o'clock. Which is usually why I do my video after 7, so that way no one has to hear him kind of crying. Because he will let me know. So if the stack is empty, then we're not gonna do anything. So if we want to say if the stack is not empty, then we're gonna do some stuff. We're gonna do some stuff if the stack is not empty. I'm gonna basically check. What was the speed calculation that he did? What's up, bro? Yeah.
I'm gonna make a function to calculate the time. Target, position, speed, and then I'm just gonna return target minus position divided by speed. Make sure I get the right target too. I'm gonna make sure bound to always be greater than or equal to 0. No negative time. I'm never going to kind of do anything with that, so. That's the speed, and put the target in there. Okay. So after we put that in the stack, so that's how long it's going to take to reach the end. Then I'm going to say oh, well, I had to kind of declare my stack a little too late. I'm going to say that pair equals pair 1 and onwards. Like a queue. Pair is a queue. Stack's a stack. Okay. Then I'm going to say current time is going to be equal to calculate time of array. Nope. Of a target. Array of, oof, wait, what am I doing here? Let me get rid of that. Might have caused some errors for myself. Array of 0. An array of 1. Excuse me, my time. Say if current time is greater than or equal to stack -1. Then I'm going to say, actually, I'm going to say if it's less, then I'm just going to stack dot append current time, and then I'm gonna say that the number of fleets have just went up. Number of fleets plus equals 1. Okay, and then I'm gonna return a number of fleets. Run it. I don't think it's gonna work. I think this is definitely gonna break. Hopefully not because of something stupid like that, but okay. Cool. So what I want to do is I want to print stack -1, and then I want to print current time. Okay, so we run this through. Current time, is it less than stack of -1? Nope, so fleet shouldn't go up. Oh, I'm doing it wrong. It needs to be greater than. There you go. And hey, that worked. That's a weird problem. I don't really like those problems because they kind of like give you a bunch of like gabagool, like a bunch of like word vomit, and it kind of distracts you from what the problem actually is. But I guess a recruiter or a tester would basically say, hey, that's the real world. It's a bunch of gabagool and you gotta figure out what's the actual deets. Okay, I'm gonna call it there. Tomorrow we can look at largest rectangle in histogram. I need to go lift some weights before I get too tired. So tomorrow we'll do that. Should I rage bait? Should I go do that and then go straight into Coco? I think I'm gonna do linkless, do reorderless. Apologies. Sneezy. Alright. Thank you for watching the video. Appreciate it. Glad you came out here today with me. And I will see you tomorrow.